together again as you will be welcome to do so. All right, so let's pull up the notes on our Google Classroom. All right, sweet. So here we are, as always, under the classwork section right here. And once we get finished today, the video will go into our class notes video section right here. But we are in week 3 of school, guys. We only got 4 more weeks left after this one, and then it'll be the end of the term. So we're already a good chunk of the way through school tonight. Hopefully everybody got around to doing the Monday assignment about answering the question regarding the particle motion of states of matter. If you didn't get a chance to do it on Monday, make sure you go back and do it sometime this week so you don't miss out on those points. But today is November 10th. Today is Tuesday. And so we are going to be talking about atomic structure. So what are atoms and how are they made up? What goes into building an atom? All right, so atomic structure and the periodic table. Like I was saying earlier, atoms are the teeny tiny, minuscule, microscopic particles that make up everything else in the universe. So everything that exists, everything that is real and in our universe is made out of atoms. Maybe it's really, really small and it's only made out of several atoms. Maybe it's huge and it's made out of billions and trillions of atoms like we are. But everything is made out of these atoms. So you, your dog and your cat, the table that's in front of you, the chair that you're sitting on, the house that's around you, the grass and the trees outside, it's all made out of atoms. The air that you're breathing right now is made out of atoms. So every single different atom that scientists have been able to determine exists so far is on a big chart called the periodic table. So each little box on this chart, the H, the Li, the Be, the O, the S, the Cl, each of these represents a different atom. So all of these little boxes in our periodic table are different atoms. And everything in the universe is made up of some combination of these atoms. So some of them you may recognize, such as helium is this guy right here, and carbon, the stuff that makes like pencil lead and diamonds, oxygen, the air that we breathe, neon, the gas that's in those colorful signs that you see in gas stations and bars. Some metals are present on the periodic table too, like aluminum is this guy right here, and zinc and copper are right here. Sometimes the little labels on the periodic table look a little bit different from what we would normally call them. So like this guy right here, AG47, this is gold. No, wait, just kidding. This guy's gold, AU. AU is gold. And PB over here is lead. It has to do with the ancient name for some of these structures, but that's not really important. The main thing is that every single box on this periodic table is a different atom. And so today we'll talk a little bit about these atoms and how we can tell important information about them based on just the facts that we have from their little periodic table box. And we'll talk a little bit either today or on Thursday about the actual structure of the periodic table itself and what some of its different columns and rows mean. So that's sort of atoms in the periodic table in general. But specifically, atoms are what we're going to be focusing on mostly for tonight. So atoms are, like I was saying, the smallest unit of matter. So everything in the universe is made out of atoms, and it's the smallest little piece of anything. So you can't build something out of any pieces smaller than an atom. The atom is sort of like the most basic building block that you can have in order to start creating other types of matter, whether that's water, whether that's air, whether that's plastics. It's all based on these atoms. So each atom is actually made up of a combination of even smaller particles. So we're going to talk a whole lot about these smaller particles today, but they are called protons, neutrons, and electrons. So today we're going to talk about what are protons, neutrons, and electrons, as well as how can we figure out how many of them are in each different atom. So here is sort of a general structure of an atom. We have this kind of central mass in the middle, right? This central cluster in the middle right here. And then all these little particles are zooming around the outside. So these little green particles are zooming all around the outside, and these red and blue particles are clustered together in the middle. So the middle section of the atom actually gets its own special name. It is called the nucleus. So the nucleus is the center part, the center kind of cluster section of our atom. Pretty much all of the weight of an atom. So atoms, even though they're so incredibly super duper tiny, they still do have weight, but it's pretty much all focused in the nucleus right here. So there are two of our different particles that we can find in our nucleus. We've got our protons and our neutrons. So the protons and the neutrons, you put them together and you get the nucleus. So the protons and the nucleus, which in this little picture down here are represented by the little red balls, the little red particles. These guys hang out in the nucleus and they have a positive charge. So each one of the particles that we're going to talk about tonight has some form of an electrical based charge on it. And protons have what's called a positive charge. So hopefully this is pretty easy to remember. Protons are positive, right? They both start with P, which is at least always how I remember it anyways. It helps me out. So the positive protons are hanging out down in our nucleus down here. Yes, Raquel, this presentation is on the Google Classroom under the 11-10 Tuesday notes one. It's the atomic structure presentation. So yeah, if you ever want to go back and look at.
I can't see it, and I'm like trying to look at it, like, you know, as you speak, but I don't see it on here.
Are you looking at the Google Classroom?
Yes.
So make this guy a little bit smaller. So they're the 11-10 Tuesday notes are what we are looking at right now. So if you go to the classwork tab of the Google Classroom under week 3, we are going through the atomic structure notes.
Found it. Thank you.
You're welcome. All right. So, like I was saying, protons are one part of the nucleus, this little center cluster right here. And they have a positive charge, so a plus charge for our protons. The other guy in our nucleus are the neutrons. So the neutrons are the second part of the nucleus. We have our protons and our neutrons together. That's what makes up our nucleus. Neutrons, their electric charge is essentially 0. So they have what's called a neutral charge. So unlike the protons, which have a positive charge, the neutrons have a neutral charge. So that's kind of where they get their name from, actually. They're neutrons because they are neutral charge. They don't have any charge at all. That's like a kind of like a 0 charge. That's what neutral means here. So the protons and the neutrons are hanging out together in the nucleus. And if you remember what I was saying a second ago, the weight or the mass of the atom is pretty much all made up of the protons and the neutrons. So if you add however many protons and however many neutrons that you have, you'll be able to figure out the weight or the atomic mass of the atom. So neutrons are neutral. They hang out in the nucleus. And if you take your protons and neutrons and put them together, you can figure out the weight or the mass of the atom.
You said to put protons and neutrons?
Mm-hmm. Yeah.
And that will give us the mass?
Exactly.
Okay.
So yeah, the mass of the atom is the protons plus the neutrons. So these are the two particles that are hanging out in our nucleus down here, right? In this little picture, we've got our red protons and our blue neutrons, and they're all crunched up together in our nucleus. But that's not the only thing that we've got in our atom, right? We've got all these electrons swirling around the outside. So the electrons are not part of the nucleus. Instead, they orbit around the nucleus. So if the nucleus is sort of like the sun in our solar system, the electrons are like all the little planets orbiting around it. So electrons are the opposite of protons. They have a negative charge. So the tricky thing about this is that sometimes people will think, oh, protons are positive, neutrons are negative. And that is not the case. Neutrons are neutral, electrons are negative. So the way that I try to remember this is that electrons, you might sort of recognize that word because it kind of sounds like electricity. And that's because electricity is made up of electrons. And so if you ever get shocked by electricity, that's going to be a very negative experience, right? It's not going to be fun to get a whole bunch of electricity going through your body. So that's the way that I try to remember that our electrons are our negative charges. So we have our positives and our neutrals hanging out in the nucleus in the middle here, and then the negative electrons zooming around the outside. So the reason why you may be wondering, wait, if we have protons, neutrons, and electrons, then why do only the protons and the neutrons get counted for the mass? Why not the electrons? Essentially, it's because electrons are, compared to the protons and neutrons, way teeny tinier than them. They're so small and light that they don't really get counted in terms of the mass. They make up like maybe 0.001% of the mass. So 99.99% is made up by those protons and neutrons here in our nucleus. So we've got our negative electrons zooming around the outside. And then in the middle, in our nucleus, we've got our positive protons and our neutral neutrons. Remember, neutrons are neutral. They are not negative. That's the electron's job, is to be the little negative charges zooming around. Neutrons are neutral. Protons are positive. All right. Anybody have any questions about protons, neutrons, or electrons so far? We're about to talk a whole lot more about them, so if you have any questions or you're confused about anything right now, please let me know.
So if we
No, thank you.
What was that, Cameron?
I said no, thank you.
Okay. Elena, were you saying something?
Yes. So for the protons and neutrons, each to find it, we just have to what, like subtract it or just have them?
Ooh, Elena, you are actually thinking ahead a little bit. That's part of what we're going to talk about coming up next.
Oh, okay, I'll just wait then.
Good call. Way to be thinking ahead, though. All right. Any other proton, neutron, electron questions for the moment before we keep going? Checking chat, making sure that there's nothing in there. Looks like everybody is on board so far. All right, so we've got our positive protons and our neutral neutrons here in the middle, the nucleus, and then our negative electrons are zooming around the outside. So up next, we are going to talk about how we can use the information on our periodic table that we saw at the beginning. How can we use information on this table to figure out the number of protons, neutrons, and electrons that an atom might have? Which is something that Elena was starting to get to without even realizing it, because she's that smart. So here is a normal periodic table box for an atom. In this case, it is specifically referring to the atom krypton. So there are 4 things that we can see on this box, right? There's 4 different pieces of information. We have the name of the atom fully written out, right? In this case, this is the atom krypton. We have the symbol or the abbreviation for that atom. So each different atom gets a different 1 or 2 letter chemical symbol. Right? So carbon is C, oxygen is O, helium is He, krypton is Kr. So just a short 1 or 2 letter abbreviation for that atom. So those are the two kind of most easiest things to see right off the bat. The next pieces of information are these 2 numbers in the box. There's usually a smaller number at the top of the box. This is called the atomic number. And then there is a larger number at the bottom of the box. And this is called the atomic mass, or sometimes it's called the atomic weight also. So we're going to talk about what each one of these numbers means, as well as what it tells us about the different particles in our atoms, the protons, neutrons, and electrons in our atom. So our first number up here at the top, the atomic number, this tells us the number of protons in our atom. So in that nucleus of this atom, the number of protons that it has is its atomic number. So in this case, krypton has an atomic number of 36. So krypton has 36 protons in its nucleus, in this atom. Every single atom in the periodic table has a different number of protons. So no 2 atoms overlap in their proton number. If you have a different number of protons than something else, then you have to be a different atom. But again, the main thing is that this number up here tells us how many protons that we have. So krypton is atom number 36. So krypton has 36 protons. And that's different from any other atom on the periodic table. No other atom has 36 protons, only krypton. All right, so that is the first of our numbers on this periodic table box. The next number, the one that's whited out on the bottom down here, is the atomic mass, also sometimes called the atomic weight. So the atomic mass is the approximate mass of one single atom of an element. So how much does one krypton atom weigh? That is what our atomic weight shows us. Now, as you might be able to guess, these atoms are so incredibly teeny tiny small that we can't measure them in like pounds or ounces or grams, right? If we did, every atom would be like 0.0000000000000000192 ounces. And nobody wants to write all those zeros out each time. Instead, scientists came up with a new unit called an atomic mass unit, abbreviated as an AMU. And an AMU, one AMU, is essentially the weight of one proton or neutron. So a single proton weighs 1 AMU. A single neutron weighs 1 AMU. This particular atom right here, this krypton, weighs 83.8 AMUs. And for the most part in this class, when we're dealing with these atomic weights, we'll round them to the nearest whole number just to make it easier to talk about them and work with them. So we could also say that krypton has an atomic weight of about 84. So krypton, the atom, has an atomic number of 36 and an atomic weight of about 84 AMUs. So something that Elena was starting to suggest earlier is that knowing the atomic weight is all good and all, but what we really want to know is the number of neutrons that an atom has. Luckily, we can use the atomic weight in order to figure this out. So, you may remember from just a short moment ago, I said that the atomic number of our atom is the number of protons that are present. So for any single atom out there, if you know the atomic number, then you know how many protons it's got. And early on, I mentioned that the atomic weight of an atom is the protons plus the neutrons. So we take our protons, take our neutrons. If we put them together, we can know the atomic weight. If we take the number of protons, number of neutrons, add them together, that gives us our weight.
So it'll be 120.
So close, but not quite.
Okay.
So if we know the atomic weight and we know how many protons that we have because of the atomic number, then if we do atomic weight minus atomic number, that'll tell us how many neutrons are in our atom. All right, so you have the atomic weight right here, the total. You take away the protons, the atomic number, so weight minus the protons. And when you take away the protons, you can figure out the neutrons. So the total minus the protons will equal the neutrons. Or the atomic weight minus the atomic number equals the number of neutrons. So let me walk you through an example right here. So krypton has an atomic number of 36, which means krypton has 36 protons. So in order to find our neutrons, right, we have to do the atomic weight minus the atomic number. In this case, we said that the atomic weight was pretty close to basically 84, minus the atomic number of 36. So when we do 84 minus 36, that will give us 48 neutrons. So again, this atomic mass is the number of neutrons and the number of protons put together. So if we take that atomic mass and take away the number of protons, then we can figure out how many neutrons our atom has. So in the case of krypton, we have 36 protons and 48 neutrons. And again, we were able to figure out these numbers just based on these two pieces of information from the periodic table. The atomic number and the atomic weight we can use to figure out how many protons and how many neutrons are in an atom.
So whenever you assign homework to us and we have to find the neutrons, do you want us to round the number? Or
Yes.
okay, because I had gotten 47.8. So if I would do it like that, would it be counted as wrong?
Nope. If you don't round the number, that's okay. But I would definitely recommend doing it just because it's easier to do. Like when you're doing it on the calculator, you don't have to put in all the little decimal places and stuff. And so yeah, on the homework and on any future like quiz or exam questions, I would definitely recommend rounding the atomic weight number, but if you don't, you won't lose any points. All right. Any questions about how to figure out the number of neutrons? All right, everybody feel pretty okay with that so far?
I do.
All right, we'll do some more examples at the end of class today just to make sure that everybody is on the same page for it. All right, so we talked about our protons, that atomic number. We talked about our neutrons, which is where we have to do minus, right? The weight minus the number. But there's one more of those particles that we're missing, our electrons. So how are we going to figure out how many electrons are in each one of our atoms? Luckily, it is super duper simple. And that is because in each one of our atoms, we're dealing with what are called neutral atoms. And neutral atoms have an equal number of protons and electrons. So in all the atoms that we deal with in this class, the number of protons is going to be equal to the number of electrons, right? They're going to balance each other out. So a neutral atom will always have the same number of protons and electrons. Because for a neutral atom, that means the overall charge on the atom has to be 0. So if our protons are positive and our electrons are negative, then that means that we need an equal number of them in order to balance each other out, right? We can't have too many positive. We can't have too many negative. They have to be equal. They have to be the same. So the most simple atom that exists in the universe is hydrogen. And hydrogen atom is simply one proton being orbited by one electron. All right, this guy doesn't even have any neutrons. He's so small. It's just the proton and the electron. But again, same numbers, right? One proton, one electron. The plus and the minus have to cancel each other out. They have to balance each other. So for the electrons, it doesn't matter how many neutrons that we have. All that matters is that we are equal to our protons.
So the one that we just worked on, it will be 36 electrons.
Bingo.
Okay.
But yeah, krypton has an atomic number of 36, which means that krypton has 36 protons and 36 electrons. Exactly. All right, let's look at another example here really quick. So here we have a carbon atom. It has an atomic number of 6 and an atomic weight of 12. So how many electrons are in one atom of carbon?
6.
6. Bingo. And Elena, how did you know that there were 6 electrons in carbon?
Because it's the same as the proton in the top.
Exactly. Electrons are the same as the protons, which are the same as our atomic number up here.
Which also has 6 neutrons.
Oh, Jonathan is thinking ahead. Jonathan, how'd you figure out that carbon has 6 neutrons?
Subtracting the atomic number by the atomic weight.
So if you do 12, which is the weight,
That's it.
minus 6, which is the number, that'll give us a neutron count of 6. So that is exactly correct, Jonathan. We have 6 neutrons, 6 electrons, and 6 protons in one atom of carbon. All right. Any questions about how you calculate protons, neutrons, and electrons? All righty. So I'm actually going to go ahead and open up a Jamboard. So we can work on a couple more examples together just to kind of make sure that everybody has got it down. And so you don't have to join on to the Jamboard if you don't want to. I'm going to share my screen so that you guys can see it on the Google Meet as well. But here is okay. That's good. All right. Let's see. Oh, here's the button I was looking for. All right, and then I got to this guy over here. All right, awesome. So let me see what would be a good one to do. Let's do sulfur. All right, so let's say, for example, we have the element sulfur, and sulfur has an atomic number of 16 and an atomic weight of 32. So I want to figure out how many protons, how many neutrons, and how many electrons that we have got in sulfur. So besides Elena or Jonathan, who can tell me how many protons that we have in sulfur?
16.
16. And how did you figure out that there are 16 protons?
Because that's the atomic number equals number of protons.
Bingo. Atomic number is 16, which means that we have 16 protons. All right, what about neutrons? How many neutrons are in sulfur?
$32.
Not quite. Remember,
16.
is the weight. But neutrons come from doing the weight minus something else.
Weight minus the number.
So if we do the weight, which is 32, minus the atomic number, which is 16. So the weight is down here, and we do minus the number. Then how many neutrons are in sulfur?
-16.
Not quite. Remember, we're doing 32 minus 16, not the other way around.
Oh, so it's just regular 16.
It's regular 16, exactly. So again, neutrons, you do the atomic weight minus the atomic number. So 32 minus 16 is 16. And then finally, how many electrons are in sulfur? Feel free to share out loud or in the chat. How many electrons does sulfur have?
$16.
16 is exactly correct. Way to go. And how did you know that it was 16?
Is the atomic number?
Exactly. So the electrons are equal to the protons. The protons are equal to the atomic number. So if the atomic number is 16, that means that our protons are 16 and our electrons are 16. And then what's left over is our neutrons, which are the atomic weight minus the atomic number, which is 32 minus 16, which in this case is, again, regular 16. So sulfur has 16 protons, 16 neutrons, and 16 electrons. All right. Let's do one more example. Let's see, let me look up another good example here. Ooh, Mercury. Could be fun. All right, let's go big for this next one. So Mercury, which is one of those kind of weird atoms because its name is Mercury, but its symbol is Hg. Mercury has an atomic number of 80 and an atomic mass of 201. So let's use this information to figure out Mercury's protons, neutrons, and electrons. So
Well, the protons are going to be 80 and the electrons are going to be 80, and then the neutrons is at 121.
I think so, but hold on. So let's slow down there for a second. I believe that's all correct. So great job. But how did you know that the protons are going to be 80?
Because that's the atomic number, and then the protons and electrons equal the atomic number.
Mm-hmm. Exactly. The protons and the electrons are equal to each other, and they're the same as the atomic number.
Mm-hmm.
So our electrons are also 80.
And then for the neutrons, you do the 201 minus the 80.
Precisely. 201 minus 80, because that is our weight minus the atomic number. So the weight of 201 minus the atomic number of 80 is, I believe that would be, 121. Just like you said. So Mercury has 80 protons because it has an atomic number of 80, and this guy is our protons. Mercury has the number of electrons is 80 because the electrons have to equal the protons. And then finally, Mercury has 121 neutrons, 121 neutrons, which we could figure out by doing the weight of 201 minus the number of 80. Gives us 121. All right, excellent job. All right, so does anybody have any questions about how to determine protons, neutrons, and electrons for an atom? This is the main thing that your homework for today is going to be over. So if you have any questions at all about it, now is the time to ask.
No, sir. Thank you. I'll submit my homework tonight.
Perfect.
Have a good day. I have to go and I'm already getting home. But I'll turn the homework in tonight.
All right, sounds good. Thanks for the update, Cameron.
Of course. Thank you. Have a good night.
Mm-hmm.
So are the protons and the electrons always going to be the atomic number?
Yes, for this class, that's going to be the case. There are some cases where we get differences in the proton and electron numbers, but that is for a little bit more kind of complex atom stuff that we're not going to go into this.
Okay.
So yes, for your homework and for any upcoming questions about anything, the protons and the electrons will always be the same number.
All right, thank you.
No problem. Good question, Crystal. Anybody else have any other proton, neutron, or electron questions? All right. So speaking of the homework, I did want to show you that really quick, just to give you a little preview for today and tomorrow. As always, if you already worked on the homework, if you already did the homework, but you realize after this lesson that you may have done some things incorrectly, you are free to go back and resubmit a new version of it. If you think you're going to do better a second time around, that is totally fine. And so the homework for today is pretty much exactly what we were just doing here. So if you do the Google Forms version, you get a atom box just like the one we were looking at. Again, these measurements can get pretty technical, so I would recommend just rounding them to whatever the nearest whole number is. So like, for example, fluorine has a weight of essentially 19. So on the Google Form version, you would just type in the proton, neutron, and electron number down here in the space underneath each picture. So each one of your answers, if you do the Google Form version, could look something like this. Obviously, these are not the correct answer. So for each atom, write out how many protons, how many neutrons, and how many electrons are in that atom. Or if you would rather do it on the Google Docs version, it's essentially the same setup with the same questions. The only difference is there is a space provided in order for you to type in the number of protons, the number of neutrons, and the number of electrons. So you just fill in the spaces next to the words down here on the bottom. So each one has the exact same atoms on it. It just differs in how you put in your answer. So again, it seemed like for the most part, you guys were pretty much understanding the proton, neutron, electron stuff that we were just doing right now. And that's pretty much everything that the Tuesday assignment is for. The Wednesday assignment that is going up tomorrow morning is basically just kind of a review of a whole bunch of stuff that we were talking about today. And so it has some like written down kind of mini notes sections on it. And then it has some questions about this atom right here, this little periodic table of this atom. And then it also asks about figuring out numbers of protons, electrons, and neutrons. One thing to pay close attention to on number 5 is that it asks about both protons and electrons. So make sure that for Wednesday's homework, you have both protons and electrons listed out for number 5 right here. There's a lot of people last term who missed that part and only put one or the other. So make sure you put both for number 5, and then the neutrons are in number 6. And again, that will be the homework that is going up tomorrow for your Wednesday assignment. Alrighty, any final questions about protons, neutrons, electrons, how to calculate them based on the periodic table? Anything like that? Any final questions?
Nope, not at all.
Awesome, thanks, Jonathan. Anybody else? Any final questions?
I can say I understood the lesson now.
Oh, good, good, good. Well, if you ever do have any questions, you can always send me a text, send me an email, or leave me a comment on the Google Classroom, and I'll